Good morning students, welcome to these digital classes in mathematics on the chapter of algebraic identities. One of the algebraic identity a plus b of a minus b equal to a square minus b square. Today you are going to learn this algebraic identity in visual representation. Okay, before going to learn the visual representation of algebraic identity, let me discuss the objectives of this lesson. The first one is the student can understand the importance of the geometry in learning of algebra. Everyone knows that in mathematics we have 5 areas, that is geometry, number system, algebra, arithmetics and data interpretation. These 5 are not different one, they are interrelated. We can explain the algebraic concepts by using geometrical concepts, and we can understand the geometric concepts by applying the algebraic concepts, like they are interrelated. So, the student can understand these importances of the geometry in learning of algebra. And second one, now we are in CCE mode. Here CCE is not a continuous comparative evaluation, but also it is a child centered education. So, the activity based learning plays vital role in the learning of mathematics. In this lesson we adopt one of the strategy as activity based learning. Through activity based learning, the children will get enjoyment by doing mathematics. In the third one, he explores various methods to verify the algebraic identities. And there is no possibility to say this is the only one method to explain the algebraic identity. We can do in several methods. Here I will explain few of them, and the children will explain or try to prove the algebraic identities in different methods. Okay. So, children, shall you have a pen and paper with you? I will ask a few questions to you. Find the value of 19 of 7, 19 sevens. Good. So, maybe all of you will get the answer as 133, correct? Okay. How you got this answer? Because from primary school educational onwards, you are learning the tables. Through the 19th table, you can calculate easily 19 sevens are 133. Okay. Shall I give one more? Find the value of 63 of 100, 63 hundreds. Yeah, good. It is 63 hundreds or 6300. So, your children maybe got answer. Am I correct? Yeah. 6300, here no need of any multiplication knowledge is required. When any number is multiplied with the multiples of 10, for example, it is multiplied by 10, the number is followed by 0. When it is multiplied by 100, it ends with 2 zeros. When it is multiplied by 1000, it ends with 3 zeros. So, 63 when multiplied by 100, 63 and with 2 zeros means simply 6300. Okay, good. I will give one more question to you. Find the value of 103 of 97. Okay. So, the difficulty level maybe rises. Am I correct? So, there is no possibility to use the table here, and there is no possibility to apply the concept beyond the multiples of 10. Here 103 of 97 means you have to first multiply with 7 and you have to multiply with 9, you have to add it, finally you will get the value of 103 of 97. Am I correct? But it may be lengthy, I think so. Now see that just some of the children maybe try to get the answer in this mode also. So, 103 can be written as 100 and it is 3 more than it. So, 100 plus 3, and 97 is 3 less to the 100. So, he will write as 100 minus 3. So, when 100 is multiplied by 100, you will get 10,000. When 3 is multiplied by 3, you will get 9. So, when 9 is subtracted from 10,000, you will get 9,991. In this manner, you can calculate it. But are you understand what kind of concept involved in this? We have written 103 as 100 plus 3, 97 as 100 minus 3. So, you can write it as 100 plus 3 of 100 minus 3. Okay. Here I am going to use a small algebraic identity, that is a plus b of a minus b, which is equal to a square minus b square. So, here I am assuming a is 100 and b is 3, then answer will be 100 square minus 3 square. Of course, 100 square is 10,000 and 3 square is 9. So, 10,000 minus 9 is 9,991. So, here you apply one algebraic identity. What is that identity? Children, can you say that? Good. It is a plus b of a minus b. Okay, so now we will see, just it is a recapitulation of a plus b of a minus b. What is its value? Like a small multiplication, general multiplication. When a plus b of a minus b, first you have to multiply a with a, which is a square, and next a with minus b, it is minus ab, b with a, it is ab. Of course, you can write it as ba also, and b with minus b square. Here ab and ab both are same words with a different sign. So, both will get cancelled and finally its sum is equal to 0. So, a square minus ab plus ab minus b square, you can write it as a square minus b square. So, finally we got the result, that is a plus b of a minus b, which is equal to a square minus b square. Here I am going to use this, is everyone knows this identity easily. Already I said you can't confine the mathematics as in a particular area, you can spread it into different areas also, and you can learn and you can prove any statement with different strategies, different methods. So, here I am adopting one of the strategies that is called visual representation. So, everyone knows it, the square of a number represents the area of a square, am I correct? For example, if you say 4 square, you can say in a geometrical sense the area of a square whose side is 4 units, am I correct? So, now I am going to use the same concept to explain the algebraic identity of a plus b of a minus b as a square minus b square by visual representation. Shall we go now? Now, see, this is a square, of each side is a units. Okay. What is the property of square? All sides are equal, good. Each angle is 90. Okay. Then what is the area of a square? The area of a square is area of a square is the side of side or side square. So, what is side here? What is the length of its side? A. Then what is its area? A square. So, this square, area of square represents a square units. Now, we will see one more. Here another one which is smaller than that first one. If we assume that each side of this square is b units, okay, then can you say what is the area of the square? Yeah, exactly correct. It is b square. Okay. Now, I want to find the value of a square minus b square, or I want to represent a square minus b square graphically or diagrammatically. Here you are seeing one square is a square units area and other square is in b square square units. So, if you subtract that area from the first one, definitely you will get the required one, which is a square minus b square. Now, I am considering a small length which is b units, whose length of the smaller side is b units. Okay. I want to put this a square in one of the corner. Okay. Then what will happen? So, here there is no restriction, you can keep that square anywhere, means you can put in corner, you can put it square center, you can put anywhere. But I am using this one concept, that is I am putting this a square of which as the b square square units at one of the corner, of course left corner. Okay. Now see that area, when you see the area, that is the remaining area. The remaining area is the total area of the square is a square. When you place another square at the left corner which has the area as b square, then the remaining part area will be how much? Good, it is a square minus b square, because we are subtracting the area b square from a square. Okay. Now I want to prove the statement, that is a square minus b square equal to a plus b of a minus b. So here just I want to cut this area from the diagonal angle from the bottom to up to the diagonal of the smaller square. See it. So like when you draw a line diagonally and you cut it into the remaining part of the square into two parts, then the figures will be seems to be like. Now verify the measurements. It is b units, correct? The rest of the part is how much? A minus b units, because the total a length is a units. So you are subtracting b units from it. Obviously it is a minus b. Then what is the length of this? It is a units. And what is the length of this? This is also a units. And what is the length of the remaining part side? It is a units. When you observe, there are two trapeziums you are observing, and the measures of those is a minus b and a. Other one is same, correct? So when you divide it into two parts, just observe it. We have two trapeziums. One is the upper part and the other one is the lower part. Okay. Now I want to just rearrange these two. When you make it, what you observe, the two parts of the cutting parts will be forms a rectangle. Am I correct? Okay. Now see the length of the rectangle. So one length is b, other length is a. Totally the length of the rectangle as a plus b. Am I correct? And what is the width of the rectangle? It is a minus b. What is the length of the rectangle? It is a plus b, and width of the rectangle is a minus b. Correct? And this area is the area of the remaining part where the smaller square placed on the bigger square. Now what is the area of the rectangle? It is a plus b of a minus b. Correct? A plus b of a minus b. Okay. Because area of the rectangle is length into breadth. Length is a plus and breadth is a minus b. So area is a plus b of a minus b. But we got this area by taking the value of a square minus b square. So we can say a plus b of a minus b is equal to a square minus b square. Correct? So very good, children. So in this manner we can learn this area of the rectangle. Of course not area of the rectangle, we can prove the statement a plus b of a minus b is equal to a square minus b square by graphical representation or visual representation. Okay. Now I am going to explain the same thing by paper folding technique, because the children should have the hands-on experience. If the children have the hands-on experience, the children can enjoy it. Correct? So now I will move to what you call it as folding technique. Shall we practice now? So okay, children, shall we perform this activity? Take a small sheet of a square sheet which has a units of length. Okay, maybe just I have taken 16 centimeter length. So each side length is 16 centimeters. Okay. So obviously the area of this square will be 16 square, or if you consider this one is a, then it will be the area will be a square. Correct? Okay. Now I will consider one more, which is b units length. Okay, see it, b units length. Okay, and if you observe this b units length square, each side is b units. Of course here I take a 7 centimeters length, and I will say in a general sense it is a b units, each side is b units. So obviously the area of this square is b square. Okay. Now I am once again taking the square, the first square, I am taking the second square. I want to place it at one of the corner of the first square. Okay. Then I will draw the lines simply and I will cut it by using scissor. Okay. Then the part will be, so when you see this, just I want to draw a line through the diagonal from the bottom to up to the end point. Okay. Then I will cut it into as per the direction. When you see this, okay, then you will get two parts. I am taking the two parts now. I will arrange in an order. Okay. Then what you observe? What you observe here? You observe that there is a, what you observe? There is a rectangle formed. You know that this length is A units, correct? And this length is B unit. Obviously, the total length will be how much? A plus B units. Okay. And that is very clear. And this part will be A minus B units, correct? So this area of this rectangle is A plus B of A minus B, and this rectangle will obtained by A square minus B square, means both areas are same because it was obtained by the same one. So obviously A plus B of A minus B equal to A square minus B square. Children, just I showed it in an animation method. Now I am exhibiting with a paper folding technique. Okay. Now I have a small doubt. The small square at exactly at a left top of the left or right anywhere. Why you put it in the corner only? No. I am not interested to follow your instructions. I will put it into at the center. Okay. When I put the center, is it possible to get the same answer? Yeah, it is possible. When you keep it at the center, okay, just draw the lines. Okay. After that, remove that square and take square and draw the lines to the corners. Okay. And cut it from the corner side. Okay. When you cut it like, you will get, definitely you will get the like 4 parts. Okay. Here your importance takes place. Now I am arranging this one in the manner. Okay, see, you have to observe it carefully. Now see, okay. So what kind of figure will form here? Just a parallelogram formed, am I correct? A parallelogram formed. Okay. So what is the area of a parallelogram? The area of a parallelogram is, anyone can you say what is the area of a parallelogram? Children, can you explain it or can you say it? Yeah, it is correct. The base into height is equal to area of parallelogram. When you observe this, here the base is A plus B units, the height will be A minus B units. Then what is its area? Base into height means A plus B of A minus B. Okay, how you got this? By subtracting B square from A square. Obviously it is A square minus B square. So A square minus B square equal to A plus B of A minus B. Okay. So like we can explain the a square minus b square identity in visual representation. Okay. So, everyone clear about this? Okay. Shall I move to practice the problems based on this identity? Yeah. Have a pen and have a book and write down the questions. Okay. I will explain few of the questions answers, then I will give it to you some more to practice. Are you ready now? Okay, good. So, okay children, just now we verified that how to visualize or visual represented the a square minus b square, which is equal to a plus b of a minus b. Here now just I make it into a small idea of purpose. Now I am leaving you to make it into a square minus b square, which is equal to a plus b of a minus b. Try it, because most of the schools have the computers and they have good knowledge about this, and the teachers also trying to give the more information how to use the animation concepts. So, children, try to practice just now what I showed to you, try it, okay, then definitely everyone will get this method. Okay. Now, I am going to ask a few questions to you. Here the first one is find the area of a rectangle whose length is 2x plus 3y and breadth is 2x minus 3y. Once again I will repeat the question. Find the area of a rectangle whose length is 2x plus 3y and breadth is 2x minus 3y. Maybe you understand this. So, this question based on algebraic identity a plus b of a minus b equal to a square minus b square. This consciousness is very important. Okay. Why you choose this identity? Here 2x plus 3y, 2x minus 3y, they are in the form of a plus b of a minus b. Am I correct? Yeah. So, the children can confirm that in this question we can use this formula. Okay. Now, coming to that, the length of a rectangle is 2x plus 3y. The breadth of a rectangle is 2x minus 3y, correct? Okay. Then what is the area of a rectangle? Length into breadth. Okay. So, what is the length here? 2x plus 3y. What is breadth here? 2x minus 3y. So, it is in the form of a plus b of a minus b. So, we can say a square minus b square. Of course, this is 2x whole square minus 3y whole square. You know that 2x whole square equal to how much? 4x square. Good. 3y whole square is how much? 9y square. So, the area of the rectangle is 4x square minus 9y square. Maybe understand the application of this question is, so there is a connection between algebra and geometry. At the same time, the children can understand how you are going to do the calculations, multiplication in easiest way. Okay children, shall we move to one more? Good. Find the value of 72 of 68. Okay. So, maybe all of you feel that this is the most easier and you can do it easily. Okay. Always you can express these two numbers with respect to a nearest number. Good. So, 72 is nearer to 70. 68 also nearer to 70. So, you can write it as 72 as 70 plus 2 and 68 you can write it as 70 minus 2. So, 72 of 68 can be written as 70 plus 2 of 70 minus 2. So, it is 70 square minus 2 square. You know that 7 square is 49. So, 70 square is 4900. 2 square is 4. So, 4900 minus 4 equal to 4896. So, how simple it is it? Okay. So, just now I explained two questions with solutions. Clear? Shall I give it some more question to your practice? So, after 25 minutes, remaining 20 minutes, the children has to do these problems, and also creating questions is one of the tool in our assessment, correct? So, informative assessment. So, children, so by understanding these concepts, all of you try to create some more questions. So, in these 20 minutes, you are able to do all these 3 questions, then you have to try to create some questions, and one more you have to explore, is there any other method to explain a plus b of a minus b equal to a square minus b square. So, try it. These are the tasks to you. Okay. Shall I give the questions to you? Okay. Write the question. Find the value of 502 of 498. Once again I will repeat it. Find the value of 502 into 498. Okay. Second one, the difference between the squares of two numbers is equal to product of sum and difference of those two numbers. Express this statement in symbolic form. All of you know this. Only we gave a sentence, you have to change it into a symbolic form. Maybe you got it. Good. The next one is the height of a parallelogram is 2 units more than a fixed number and base is 2 units less than the same fixed number. Find the area of parallelogram. If the area of the parallelogram is 21 units, then find the value of fixed number. A little bit of application, correct? But very simple. I will read once again. The height of a parallelogram is 2 units more than a fixed number and base is 2 units less than the same fixed number and area of the parallelogram is 21 units. Then find the value of the fixed number. Clear? So, like we can give so many questions based on this area, that is algebraic identity, and try to construct or prepare or form different questions on the same area. Okay, then you are able to understand the concept easily. And one more, I try to visualize in 2 different methods. So many methods are there, definitely children try it, try to explore a new method. So, definitely we will meet you after this class. Okay. Happy learning. Thank you children, thank you for listening.